All right, hey class, we're going to continue our ecology unit. This time we're in activity 7, thinking about energy flow through ecosystems. All right, here we go. So activity 7, energy flow through an ecosystem. We started thinking last time about producers, consumers, how we generate energy and food in an ecosystem, and today we're going to study that energy flow even more. So as you read through the introduction, make sure you think about that. What is a producer? Those that take sun energy and convert it into chemical energy, and then consumers are those that can't produce their own food, so they're going to have to feed on other organisms to get their energy. So when you're reading through the introduction, you're going to read about kelp forests. Make sure you pay attention to some of the new vocab words that we introduced, such as decomposers and food web. Hopefully that's a little bit familiar from the last activity. But what we want to think about is, if I give you a diagram of an organisms in an ecosystem, how do you know which way the energy is flowing? How could we find a path through there? You can make some guesses. You're pretty knowledgeable, but without full information, we don't know which way energy is going. So then we need to be able to construct a food web. So we would start with the sun. We see its energy coming into our producers, those that create their own energy, and we can see how it moves through the ecosystem. Interestingly, you'll notice something over here where there's some waste being created, and how that can feed back into other organisms as well. That's where decomposers are going to play a role as well. So the challenge question is, how can we use food webs to predict the short and the long-term effects of a particular events on an ecosystem? So how do we take the information we know about the way energy flows and think about, if there's a change, what impact will it have on the ecosystem? So what we did is we took these organism cards. There were 13 of them. So we had 4 producers. We started with giant kelp because we're considering a kelp forest, but we saw some other types of kelp and phytoplankton and cyanobacteria. You can see on all of them that they're able to take in energy from the sun and then convert that into chemical energy, and will produce oxygen and other wastes that can actually be helpful for other organisms within the ecosystem. We then saw examples of other types of organisms that live in the ecosystem. We noticed we were given information about what they feed on. So you can see, like, the rockfish will eat algae and plankton, bacteria, so they'll eat dead and decaying organisms, so that's going to put them into the decomposer category, because they're able to break down dead organisms and keep those nutrients flowing. We had some other ones here, and then the sea otter. Who doesn't love a sea otter? And so ultimately what we wanted to be able to do is take the information we know about how they're getting energy, what they're eating, and try to construct a food web to see how the energy would flow through. And this was just a sample that was provided as a way that this could happen. So you start with kelp at the bottom. You see that a sea urchin would eat kelp. You see some of these other organisms that would also eat sea urchins. So whether it's through a rockfish, which a sea otter eventually eats, or a sea otter could just eat a sea urchin directly itself. Again, bacteria over here are playing a role as a decomposer. Bat stars are also playing a role of decomposers in this ecosystem. When we talk about things like producers, consumers, what we're really talking about is, how do we classify organisms based on how they get their energy, and scientists like to call that their trophic level or their trophic role. So you have producers, you have consumers, you have decomposers. The other thing when we think about consumers, we can think about is that we see levels. So we have our producers down here in the bottom, but then we have these 3 levels of producers moving up. So consumers moving up. So if you think about that, these are what we're going to call our primary consumers. So these are the ones that are eating producers directly. So their energy is coming straight from the producer. Secondary consumers, like this row here, are things that are going to eat the primary consumers. That's how they get their energy. And then tertiary consumers are those that are up towards the top. Interestingly, you can find some that would be a primary consumer or a secondary consumer. So if you look at, let's say, a rockfish, It can be a secondary consumer when you think about it in terms of sea urchin, but it's actually just a primary consumer when you think about it in terms of phytoplankton, because the arrow is coming straight there. So it can get that same energy either through another organism or just sort of going to the source itself. And so then this was just a list of, as you try to lay out what role, what level each of those play, what trophic level. Finally, we can take that information and put it into what we call an energy pyramid. So this allows us to see the energy in the system. So energy comes in from the sun, starts at your producers, and then works its way up through your levels of consumers. If you're thinking about how much energy is available, obviously the sun's the most, and then the most within the ecosystem itself, the chemical energy would be at the producer level. As you move up each level, there's less available energy. And one question you might ask is, where is that energy going? And a lot of it is being lost as metabolic heat. So during the metabolic process, heat is one of the byproducts. And so yes, while you start with a large amount here, it is lost as heat as those organisms live and survive. So as you get to the top, you would see the least amount of available energy. So just a reminder of some of the key vocabulary we were looking at. If you aren't quite sure on some of these words, then take a look back through your notes, take a look back through the reading, and let me know if you have any questions. So I hope that helps give you an idea of how energy can flow through an ecosystem. As always, if you have questions, let me know. And otherwise, we look forward to seeing you back in class.